Hello everyone, hope you're doing well. Thank you for joining AWS Summit Online and welcome to this session. I'm Donnie, Senior Developer Advocate for AWS, and I'm super delighted to be here and share with all of you about DeepRacer. This session is structured to help you get started with AWS DeepRacer. So by the end of this session, what we really hope is for you to have some understanding of what reinforcement learning is and how easy it is to get started with reinforcement learning to start and train your own DeepRacer model. So you can take part in one of our DeepRacer League, or going out and creating your own community race. And big shout out to Accenture, our exclusive AWS DeepRacer presenting sponsor, who provided exceptional leadership and participation during the inaugural year of the AWS DeepRacer competition, running the largest private AWS DeepRacer League in the world. The Accenture AWS Business Group, or AABG, is the driving force for the collaboration between Accenture, AWS, and our joint customers through one-of-a-kind partnership. AABG delivers the best of AWS services and Accenture's unparalleled breadth and depth of industry and technology experience. For more information, go to accenture.com/AABG. This is how we structure our session for today. We will start with talking about the origin of DeepRacer and a few components that you need to know. Then, we'll shift our discussion to reinforcement learning. We will cover an overview of reinforcement learning, few terms that we will use, and how reinforcement learning works in DeepRacer. We will also guide you how to build your first reinforcement learning model for DeepRacer with our step-by-step console walkthrough. And after you have your model, now it's time to participate at AWS DeepRacer League presented by Accenture. For those who are not familiar with DeepRacer, don't worry. Let's watch the following video to get an idea of what DeepRacer is all about.
Welcome to the AWS DeepRacer League 2020 presented by Accenture. These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning.
From the day the AWS DeepRacer League competition was announced, Accenture has been all in.
We're thrilled to be part of the DeepRacer experience.
Pretty exciting, isn't it? Imagine that you can build an artificial brain for navigation and plug that into your device. So you might already have a big idea on what AWS DeepRacer is. AWS DeepRacer is a 1/18 scale robotic car which gives you an exciting and fun way to get started with reinforcement learning by applying it to autonomous racing. So we launched AWS DeepRacer in 2018 to get developer hands-on with the machine learning, and last year, AWS DeepRacer has enabled tens of thousands of developers globally to learn and get hands-on with reinforcement learning through the AWS DeepRacer League, the world's first global autonomous racing league. AWS DeepRacer Evo is the next generation in autonomous racing, unlocking new challenges and new race formats. AWS DeepRacer is also an integrated learning system to help developers from any level to understand reinforcement learning and how to apply it. There are 4 components in AWS DeepRacer. The first one is AWS DeepRacer Evo. DeepRacer Evo expands the learning and racing with new sensors that enable it to detect objects. We are swapping out the single camera and putting into a stereo camera and a light detection and ranging sensor, or known as LiDAR sensor. These sensors unlock new possibilities, resulting in new race formats that we introduced last year at reInvent 2019. They are head-to-head racing and object avoidance in addition of time trial. Second is a 3D racing simulator that you can find in the AWS DeepRacer console. So you don't have to wait for your physical DeepRacer to start learning. You can start now in the AWS console. The 3D simulator in the AWS console is where the building takes place. And it's really your starting point to build your machine learning skills for building machine learning models. And once that you have that kind of confidence, you can showcase during any race competition, which is a good segue for the next component, AWS DeepRacer League presented by Accenture. You can build models to get ready for racing in the 2020 AWS DeepRacer League, either in person or virtual. And you can also build models to race against friends and colleagues using the new community race feature. So that's all the components in AWS DeepRacer. And I just want to reiterate that you can start learning right now by logging into AWS DeepRacer console. We need to lay a foundation first before we can start building our model. So with that, let's cover the basics of reinforcement learning. Let's see how reinforcement learning fits in the AI context. Artificial intelligence seeks to create machines that seem to have human intelligence. Now, this is the general concept. One aspect that humans are good at is learning how to classify things or events, and also make simple predictions based on past behavior. Machine learning is a subset of artificial intelligence that aims to replicate this human ability. Machine learning uses statistical techniques to build models that are good at making predictions. These statistical techniques learn from data to figure out what the patterns are that ultimately leads to the prediction. Machine learning has three main categories. With supervised learning, we can build a model to predict a value or to classify data. Models are trained using large amounts of curated training data with labels. With unsupervised learning, things are a bit different. Models are trained to identify similarities in large amounts of data to aid classification. And training data doesn't have explicit labels. And with reinforcement learning, we finally can build a model to autonomously predict which decisions to make in a specific environment. Now, the models are trained in a simulated environment where the models can interact with the environment and learn based on the outcome of actions if an action was good or bad. And there was a quick overview for three main categories in machine learning. Let's get into a concrete example to illustrate how reinforcement learning works. Essentially, reinforcement learning is built on an idea. For example, when was the last time you used a reward to incentivize the right behavior of your pet? Think about our approach used to train our pet. We give cookies for good behavior and no cookies for bad behavior. Now, during this training, we instruct our pet with simple actions like sit, or stay, or roll, or even more complicated actions. Now, the goal of this game, of course, is for your pet to do all kinds of tricks. From training our pet as an example, let's dive deeper into reinforcement learning by understanding few terminologies. To be more detailed, reinforcement learning is a machine learning technique that enables an agent to learn in an interactive real-time environment by trial and error using feedback in the form of rewards from its own actions. So within the simulator, we have an agent that acts autonomously in a given environment to reach a specific goal. So what is our agent? The agent is the AWS DeepRacer vehicle. And what is the goal of the agent? The goal is to finish a lap around the track. Now, the environment is the surrounding area for our agent interacts. In this case, the environment is the track we designed with AWS RoboMaker. The state is defined by the current position within the environment. Now, basically, this is what the agent can see through its camera. The action can be defined with how fast or how slow the agent decides to run, and it can also be including the direction. For every state, our agent needs to take an action to try and achieve its goal of making a lap. And depending on which action it takes, it will be given a reward. If the chosen action gets the agent closer to the goal, you can reinforce this action in future through a positive reward, or otherwise discourage it with either a negative reward or no reward at all. Now, this reward is provided by the environment itself and specified by a reward function. A reward function is code written to incentivize behavior through parameters defined by the creator of the environment. Now, the last concept here is an episode, which represents each iteration where an agent goes from the start position to a termination state. A termination state means if it drives off the track or finish a lap around the track. So those are the terminologies that we need to know so we can fully understand the whole concept of reinforcement learning in AWS DeepRacer. Okay, so we got it now. We have an agent which interacts by doing some actions within the environment, and it will be rewarded depending on how close or far from the goal. So what is the most crucial component to help us creating the reward? And yes, it's a reward function. The reward function incentivizes particular behaviors and is at the core of reinforcement learning. To run your AWS DeepRacer car, providing a reward function will be your most important job. Let's look at this race grid to see a practical example of a reward function. Now each square is a state, and the green square is the starting position, while the finish line is the goal of terminal state. Now we design the square at the edge of the track as a terminal state, which will tell the vehicle that if it has gone off the track and failed. A reward function is a function to help your agent to determine if the action you just took was good or is it bad, based on the outcome of the action. The reward function is a logic that looks at the next state the agent is in and based on that assigns a reward. The reward function can be seen as the logic that will incentivize the driving behavior you want your agent to learn. How will you incentivize the agent to drive on the yellow center line? By assigning a higher reward to the center line, our model will learn that actions that drive on the center line gets higher rewards than actions that leads to the sides. Initially, our agent won't have any idea of the value of landing in a state or the reward associated with an action. So it first needs to explore the environment and then explore some more in an iterative fashion to build up this knowledge.
Our model starts off not knowing anything about the reward for specific actions, and then repeatedly explores the grid until it moves out of the track or reaches the destination before it starts again. Our model is learning through iteration. As it drives around, the vehicle accumulates rewards from the scores we have defined. Besides recording each step, it is also learning what rewards the various actions from a specific state leads to. Now, all steps from start to going off track or the finish line is called an episode. To get the best model, the agent first needs to explore the grid to ensure it covers large rewards that can drastically change driving behavior. Now, this is normal and we call it exploration. First, the agent needs to explore to see what rewards can be obtained from various actions tried in the various states. It won't settle for the first best thing, it will first explore. As the agent gains more and more experience through the exploration and iteration, it starts learning where it repeatedly gets higher rewards. It then starts exploring less and moving on to exploring what it has learned. Now, convergence happens when a model starts repeatedly picking specific actions depending on the state it is in. Now, the model is optimizing for expected cumulative return and model performance will be the same repeatedly, with subsequent updates to the model not really changing the model behavior. However, there is a trade-off between exploration and exploitation, which you need to configure with a hyperparameter. If you explore too much, your model may take a very long time to converge. If you exploit too soon, your model may not find the best driving behavior and potentially also fail to converge.
Now let's go back to the previous race grid. So what we have here is a small grid, and our agent can easily go to each square and test all actions to determine which action will result in the highest expected cumulative reward. Assuming that in each subsequent square, it will choose the action with the highest expected cumulative return. Now this mapping where we know the value of being in a square is called a value function. And once we know the value of a state, we simply choose the action that takes us to the highest value. Now, if you can map all the state directly to an action, then you have a policy function. And the model is sometimes called a policy network. Now, the idea of knowing how valuable it is to be in a state is a very important concept. The value of being in a state can be seen as the expected cumulative reward that can be achieved from the state onwards if the agent keeps following the optimal policy. So let's recap what we have discussed about reinforcement learning in AWS DeepRacer. Reinforcement learning being a form of machine learning where we are interested in creating a model that can learn how to make autonomous decisions in an environment based on the reward that it receives when it interacts with the environment. Reinforcement learning in the real world is like training your pet to behave using cookies as rewards. The reward function is the logic that incentivizes our model to learn the driving behavior we want the model to do. In a grid world, our agent first explores the environment to learn what rewards can be achieved from each state based on the various actions, and the reward function is the logic that assigns a reward based on the outcome of each action. It uses this interaction to build a map of the value of being in each state. Now, the value of being in each state is the expected cumulative reward that can be achieved from the state onwards when following the optimal policy. But how does the DeepRacer agent learn? In DeepRacer, our agent is the car, and it interacts with the simulated racetrack environment during training. In the simulator, AWS DeepRacer drives around the track taking pictures about 15 frames per second. That picture is our state. Now for each picture, DeepRacer will take an action and end up in a new state, and this is called a step. DeepRacer Evo has stereo cameras and LiDAR sensors, so it has a more in-depth view of its state and can sense objects too. DeepRacer will collect experience, the state, action, reward, next state tuples, and all steps from the starting point until it reaches terminal state, and this is called an episode. Once the agent has collected experience, which you need to specify in hyperparameters, it starts updating and training its model. Now the goal during training is to figure out which action in which state will lead to the maximum cumulative expected rewards. Now once the model is trained, it is sent back to the agent to collect more experience, and as for the exploration and exploitation, once again is controlled through the model hyperparameters. However, unlike the grid race, DeepRacer cannot explore all states in the simulator. It will simply take too long, if not impossible. So we cannot fully determine the value of ending up in each state. Now the next question would be, how do we select the action if we don't know the value of the states? Now the answer is approximation. This is commonly referred to as policy optimization, which means we optimize the policy function mapping state to action in order to achieve our goal. Let's look at a common method of doing policy approximation using a method called vanilla gradient ascent. Vanilla policy gradient is an example of policy optimization. Now this is a method where we parameterize our policy function. Now the parameters are simply the weights in the neural networks, and the neural network represents our policy function. Now essentially, this policy function takes an image as an input and maps the output as an action. We then optimize that policy to get the best action from each state, and our goal is to get the maximum cumulative reward. We train our model, updating the weights by trying to maximize the cumulative future reward, and in doing so, we give higher probability to the action that leads to the higher cumulative future reward. DeepRacer uses a form of policy optimization called proximal policy optimization, or PPO. Here is the neural network architecture that we use in DeepRacer. The default architecture is a simple 6-layer network. However, you can also choose to use a deeper 8-layer network. The first layer is an input layer, and this is followed by a 3-layer CNN to help identify the features from our images needed to make driving decisions. Finally, we have 2 fully connected layers to help determine what action that this agent should make. Think of this neural network as a mathematical formula, with each node in the network determines how much weight should be placed on certain features in the image. And when the weights for a certain action all become big enough, the output of the network will indicate a higher probability for the specific action. Now during training, these weights are adjusted. Weights are adjusted so the car maximizes the expected cumulative return during racing. AWS DeepRacer is built on top of various AWS services. Amazon SageMaker trains the model. AWS RoboMaker provides the simulation environment. Amazon S3 stores our models. Amazon CloudWatch stores the logs. And finally, Amazon Kinesis Video Streams displays the video in the console. So when you start training a model in AWS DeepRacer, this is what happens. AWS DeepRacer starts Amazon SageMaker and AWS RoboMaker container in your service account and link these two. It then passes the right parameters to start the training. The experience tuples, which is state, action, new state, and reward, are generated in AWS RoboMaker. After a specified amount of experience, which is defined by the hyperparameters, is obtained, it is sent back to Amazon SageMaker to train the model. Now the new model is then sent back to AWS RoboMaker to get more experience, and the process continues. The output models, video, and metrics are stored in other AWS services such as Amazon S3, Amazon CloudWatch, and Amazon Kinesis Video Stream. Now once that you have your model ready, you can download and plug into your DeepRacer device. DeepRacer is powered by Intel OpenVINO to enable model optimization for fast inferential on the edge. So these are the technical specs on what's going on under the hood of AWS DeepRacer Evo. It runs on Intel Atom processor with 40GB of memory. It has built-in Wi-Fi, which we need to connect during the physical event to control the car. It also has 4-megapixel camera with 360-degree and 12 meters scanning radius for LiDAR sensor. And the application inside runs on top of Ubuntu operating system with Intel OpenFino toolkit and ROS Kinetic. It has 4 USB Type-A ports, 1 USB-C port, 1 micro USB, and 1 HDMI. With all of these ports, it makes DeepRacer pretty much configurable for future upgrade. One of cool thing which powers DeepRacer is OpenFino toolkit. OpenFino stands for Open Visual Inference and Neural Network Optimization, a free toolkit released by Intel to help developers and data scientists speed up AI and deep learning workloads, streamline deep learning inference and deployments, and enable easy heterogeneous execution across Intel platforms, including accelerators. The Intel distribution of OpenFino toolkit is embedded inside the DeepRacer. This means that you can easily take the reinforcement learning models that you've just trained and use the toolkit's model optimizer to convert and optimize your trained model. In DeepRacer, the inference engine allows you to deploy on the Intel Atom processor. Now, with the standalone version of the Intel distribution of OpenFino toolkit, the inference engine allows us to deploy across multiple Intel architecture. OpenFino is also framework agnostic, so you can use the powerful optimizer on models trained to TensorFlow, MXNet, or PyTorch, and then use the inference engine for high-performance inferencing. Okay, so we have covered most of the things that you need to know about DeepRacer, and let's go through the console to help you get started for building your first model.
So here we are at the DeepRacer dashboard. As you can see, there are a few links including video to help you get started and participate at AWS DeepRacer League. And also make sure that you're in US East 1 region. On this page, you'll see that there are a few virtual races happening with different racing formats such as time trial, object avoidance, and head-to-head racing. So keep your eyes on this page as we're rolling out new virtual league throughout the year. You can also view the current leaderboard to see the ranking position and also to watch the evaluation video. Like what we have right here is an evaluation video for object avoidance race in March 2020. In this racing format, your model needs to complete the lap and also to avoid any objects on the track. As we mentioned, there are a few other racing formats, for example, head-to-head racing. In head-to-head racing, there are a few bots assigned to compete with your model. As you can see, that the model is now trying to overtake the other bots as they race on track. One feature that I would like to highlight is community races. Community races is one of cool feature that we launched at re:Invent 2019. And with this feature, you can organize your own private DeepRacer competition and invite your friends, colleague, or wider audience by sharing the link once you have created your competition. And now, let us guide you to build your first reinforcement learning model for DeepRacer. First, click on the Get Started link on the navigation menu, and you can see the diagram, and these are the steps that you need to follow through. Next thing that you need to do is to check your account resources. See if you have valid AWS DeepRacer resources and valid IAM roles to start building your model. You only need to do this once, and you don't need to do it again if you don't have any issues. If you want to complete your understanding about reinforcement learning and AWS DeepRacer in particular, you can go click this button, Start Learning RL, which will take you to a microsite that we designed to walk you through the basic stuff. This microsite is structured to equip you with all information needed to get started. It is very well documented, and we like to encourage you to learn from here as a starting point. Next step on this page is you can start to create your model and race. And if you want to learn about sensors and racing formats, you can click the link on step 3. However, we'd like to recommend you to build your vehicle first and customize it in your garage page. In this page, you can configure your vehicle so you have a sense of understanding on how your reward function and hyperparameters will be affected, as it highly depends on the vehicle that you have. So let's start creating a new vehicle. On this page, you'll be given a set of options to modify your sensors, from camera to LiDAR sensors. For camera, you have two options. They are single lens camera and stereo camera. Single lens camera or mono camera has 120-degree field of view and more suitable to handle simple autonomous driving tasks, such as time trial. A stereo camera has two lenses that capture images to determine the depth of observed object. The depth information from a stereo cam is valuable for the vehicle to avoid crashing into obstacles or other vehicles in the front. So this is why stereo camera is more suitable for object avoidance and head-to-head racing. However, these two stereo cam makes training to converge more slowly. There is also an option for you to add more sensors. In this case is LiDAR sensor. A LiDAR sensor uses rotating lasers to send out pulses of light. The direction of and distance to the objects that a specific pulse hits are recorded as a point around the LiDAR unit. LiDAR helps detect blind spots of the host vehicle to avoid collisions while the vehicle changes lanes. And by combining LiDAR with mono or stereo cam, you enable the host vehicle to capture sufficient information to take appropriate actions. But it also comes with a trade-off. The neural network must learn how to interpret the LiDAR data, and in results, the training will take longer to converge. So the bottom line is understanding sensors for your vehicle is essential to achieve the best model performance. If you're going to race in time trial, one configuration that you can choose is you can go with choosing monocam without LiDAR sensor with 3-layer CNN. If you're doing head-to-head or object avoidance, then the task will be more complex, and you will need stereo cam and LiDAR sensors to help the vehicle choose appropriate action. You can do trial and error, tweak and tune based on your model's result. Cool, so we have covered this part. Let's go to the next part, action space. We frequently mention regarding action in DeepRacer. That action is actually defined by the action space, which the vehicle reacts with a specific speed and steering angle. In reinforcement learning, there are two kinds of action spaces. There are discrete and continuous action space. In DeepRacer, we use discrete action space. For a discrete action space of finite actions, the range is defined by the maximum speed and the absolute value of the maximum steering angles. So we have two components here, steering angle and speed. Each of these two components also have granularity. You can try to adjust each of these, and on the table below you'll see the changes. Remember that the more granular you define the action space, the longer it will be to train your model and to finally converge. Once that you are satisfied with the configuration, you can give a name to identify your vehicle during model training. Now it's time to create your model. Start by typing your model name, then you'll need to choose the track. We can see that there are a few tracks that you can choose. You can pick the most similar track with what you're going to race on. But remember, there's no guarantee that your model will be good. By having the most similar track, it might maximizes the odds for your model to get best performance. Next, you'll need to choose your race type. Either as a time trial, object avoidance, or head-to-head racing. And finally, choose the vehicle you want to use for this model. Next, here's where the fun begins, reward function. Reward function in DeepRacer is written in Python, so all of these lines of code are in Python. Let us share a few things to help you understand what reward function is. A reward function is a logic for how you would like to reward the agent when the vehicle moves from one position to a new position. So each time it moves, it will get another reward. The design of the reward function should be like an incentive plan. Different incentive strategies could result in different behaviors. A good practice is to create a reward function from a simple scenario. You don't need to have a complicated reward function at the beginning, as you can start small and enhance it along the way. Let's now look at some example of reward function. If you click on the reward function examples button, you'll get a pop-up dialog for you to understand some basics. There are follow the center line, the default one, stay inside the two borders, prevent zigzag, and lastly a reward function designed for object avoidance and head-to-head. Let's take a simple reward function, the default one, and review it. This reward function helps to rewarding the agent to follow center line. The function leverages two variables, track width and distance from center. Both are the parameters supplied by the environment. From there, it creates three virtual markers to identify how far away the agent from the center line. Marker 1 indicates if the agent is in around 10% of the track width. Marker 2 indicates if the agent is in around 25% of the track width. And lastly, if the agent is in around 50% of the track width. Logically speaking, if the agent is in marker 1, which is the smallest area among those three, we should reward the agent more. And that's what we did. We give better reward if they can stay close from the center line, and they are indicated on these lines. Finally, if the agent is not around those three virtual markers, we can assume that the agent is crashed and give a really small reward. So it will discourage the agents to do the particular action in the future. Pretty simple, isn't it? Now, while you're building reward function, remember that you're going to get what you incentivize and not what you intend. That's why structuring the logic for reward planning is more crucial. If you'd like to know more about the parameters, you can go to this page. As you can see, all parameters are listed here along with the description and the variable tab. Okay, so we've covered the variables and reward function, and next in our bucket list is hyperparameters. So what is hyperparameters? Hyperparameter is a set of variables that affect the training process, which highly depends on which algorithm you're going to use during training. As for DeepRacer, it uses PPO or proximal policy optimization. And this algorithm has parameters which is shown on the screen. Now, understanding hyperparameters could be daunting at first, but don't let that stop you. If you're just starting out, you can leave all of these values with their default. And you can try to learn this along the way. Let's quickly cover a few of these hyperparameters. Gradient descent batch size refers to the most recent random sample experience from an experience buffer and used for updating the neural network weights. Setting batch size will help us to reduce high correlation from input data. Number of epochs refers to how many passes does it need to update the neural network weights. The learning rate controls how much a gradient descent or ascent update contributes to the network weights. You can use a higher learning rate to include more gradient descent contribution for faster training, or you might want to make it lower to have a more stable model. We talked about exploration and exploitation before, and entropy refers to the degree of uncertainty used to determine when to add randomness. This entropy value will diminish until your model converges. And lastly, discount factor specifies how much of the future rewards contribute to the expected reward. If you want to obtain a robust model, training must provide your agent more or less evenly distributed sampling from action spaces. And a balanced combination between exploration and exploitation is required. So, for example, to have a robust model, you will need to configure your learning rate, entropy, and batch size. And sometimes you want to speed up the learning process, which that means you'll need to configure learning rate, batch size, number of epochs, and discount factor. So that's how you craft reward function and tune your hyperparameters. It requires trial and error and patience. This is an example of reward graph of a model that I've trained for 8 hours. The blue and red lines indicate average percentage completion, and the green line indicates average reward. A training job is good if the average reward and track completion showing trends to converge. Most of the times when you see the track completion hits 100%, and if you see the average reward is on the same level, your model is likely to converge. Once that you have trained your model, you want to evaluate the performance of your model. To do this, you can start the evaluation in the next section below the training. Once that you have done the evaluation, you will see the results of your performance.
Congratulations! At this point, you can build your own DeepRacer model and even tweak and tune your hyperparameters to get your best model performance. You are now ready to participate at AWS DeepRacer League presented by Accenture. Here are a few things that you need to know about DeepRacer League. Launched in March 2019, the AWS DeepRacer League had tens of thousands of developers race in person and online to see who takes home the championship cup. There are 2 ways to race. First is a physical race at AWS Summit, and other one is to race on virtual circuit. Virtual circuit happens throughout the year, so watch out for the new race release on the DeepRacer console. With Evo's new stereo cameras and LiDAR sensors, it enables 2 new racing formats in addition to time trial racing. In time trial racing, you race against the clock in a single car on track, race to see who gets the fastest lap. In object avoidance format, you'll have a time trial race, but with the added challenge of navigating tricky objects on the track. And lastly, in head-to-head racing, you'll race your models directly on the track against another model to see who crosses the finish line first. And for the virtual circuit, thousands of racers race in virtual race with time trial, object avoidance, and head-to-head racing format. The virtual racing community is continuously pushing new boundaries, from hyperparameter tuning, reward function crafting, all the way to creating their own virtual tracks. Accenture is a global professional services company with a deep history of helping customers around the world build artificial intelligence and machine learning powered solutions with AWS services. Together, Accenture and AWS bring the best of both worlds to accelerate innovation in the cloud. In 2019, Accenture launched the world's largest private DeepRacer League to date, featuring physical and virtual race. The Accenture League champion was a top 16 finalist at AWS DeepRacer Championship Cup at AWS re:Invent. Learn more about AI with Accenture at accenture.com/AI. And don't forget, here are additional resources for you to learn more about AWS DeepRacer. Big shout out to DeepRacer Slack community, which you can join at join.deepracing.io. You'll find yourself a vibrant and helpful community if you want to learn with fellow developers across the world. Thank you for joining us in this session and had some fun together with AWS DeepRacer. Hopefully, this session helps you to understand how reinforcement learning works and how to get started with AWS DeepRacer. Once again, thank you everyone. I'm Donnie, and see you on the track.
As a solution architect, having an AWS certifications allows me to measure how much I know about AWS solutions. I would recommend the AWS training classes because they are able to offer you information that is direct, comes from AWS platform themselves.
I started with Solution Architect Associate and then SysOps Administrator Associate. My journey towards SysOps Administrator Associate came out when I was trying to build a solution. Then suddenly, it came out like it is going to cost me a huge bill. That's where the SysOps Administrator Associate gives that kind of knowledge. Day to day, most of the administrators spend a lot of time on fixing the application issues, where the SysOps administrator, particularly on a AWS platform, will give much more insights how to troubleshoot and fix the application side. So definitely it's worth spending some time to do the multiple certifications.
Professional level certification is quite challenging to get. It definitely validates a person who has actual skills. And I would suggest to take it to an engineer who really think he's at that level, when he can prove that he can work on quite challenging problems.
My name is William Notowidagdo. I'm the head of engineering at Travellingcom. We are the first and the largest business platform B2B marketplace where we help micro to small medium enterprises to help grow, scale, and sustain their business needs. We help business by providing them on-demand workforce in our on-demand workforce platform that we call Big Agents. We are born in the cloud, so we have experienced two different companies before we choose AWS. Why we choose AWS? Because first, it's technology. It's actually what we need at that time. But also, AWS have a more complete ecosystem, community, and support that we need. We also have good experience in terms of managing our infrastructure in AWS compared to our previous cloud. And it also helps us to attract talents because they know that we are using AWS. Our workload on the cloud is critical to our business, so we have to attract good talent to ensure that they can operate our workload. Most of our workload is already on AWS right now. We started from our development environment, our CI/CD, which is rely on AWS code build, code pipeline, and code deploy. We also use AWS Lambda, and our data scientists also utilize Amazon SageMaker in their machine learning modeling activity. We run our marketplace website on AWS, and also our data warehouse is on top of Amazon Redshift. We deploy our web services and API to Amazon ECS. And for storage, we use Amazon S3 and RDS. We also utilize Elasticsearch to power our product search, which is vital for e-commerce company like us. We moved from our previous monitoring solution to Amazon CloudWatch. For a company like us, cost optimization is everyday job. By using CI/CD on top of code build, we optimize our CI/CD because we only pay for the build time, not the EC2 that running all the time. That kind of technology help us to innovate faster. So we can start a lot of new projects. Before that, it took 3 days, 4 days to be able to set up one project. But with CI/CD, we don't care. We just start the project with small configuration. So it helps us to innovate faster too. Our big agent business is growing pretty fast. We started big agent in December 2018, and we have around 400 agents that time. Last month in June, we have 120,000 agents. So it's been pretty successful growth in terms of the agents. That means that our big agent workload is accepting exponential incoming requests. But despite of that, we still able to see only a fraction of cost that being added to the infrastructure cost. AWS help us scale with the infrastructure, the compute resource that we need, but the cost is still optimized. For business owner, which is our customer, availability is important thing. So they want to be able to use our system whenever they want to use, and business could happen anytime. And by using AWS, we have that kind of availability that we need. For our business platform, we want to reach more and more MSMEs. And for our on-demand workforce, Big Agent, we want to reach more people and more business to help them with their business needs, but also to have people's life better because they have additional job that they can take in our on-demand workforce platform. We believe digital economy is up and coming already in Indonesia, and by doing what we are doing right now, we believe that we help micro to small business enterprises to be able to adapt to the new digital economy. We're not just doing business, we're empowering business and people at the same time. And we're also helping our country to be able to do more in the digital economy. We saw what AWS did with big companies at massive scale. So we are pretty confident that AWS will be able to support us for years to come.